Hi, this is Isaac.
That's Jabril.
Behold, Nicholas.
The linear feedback shift register, or LFSR, generates a random number from a linear seed. This Verilog module generates a random number between 0 and 37 using a 6-bit LFSR. On each clock pulse, the LFSR shifts its bits and inserts a new bit based on an exclusive OR of the two most significant bits. A reset input ensures the register starts from a given non-zero seed. The final output is the LFSR value modulo 38, covering all roulette positions from 0 to 36 and 0, 0.
Our second module takes care of our game logic. So the code takes in a clock, a reset, a signal indicating that the wheel is being spun, and another signal indicating that a bet is being placed. It also takes in values indicating how much money is bet and where it is placed. An 8-bit register is used to store the amount that is bet, and a 6-bit wire is used to store the number generated by the LFSR. And always block that activates at the positive edge of the clock handles our actual game logic. If the reset signal is received, all bets are zeroed and the balance is returned to 100. If the signal indicating a bet is being placed, then in this case the values for the position and amount of the bet are updated. And if the signal indicating the wheel is being spun is received, the payout is calculated as 36 times the bet amount of the winning bet, and then the player's balance is updated. After this, all bets are cleared so the player can play another round.
So finally we come to the test bench, where we first define the necessary inputs and outputs like the clock, reset signal, spin trigger, bet enabler, chosen bet position, and wager amount. The game module, roulette game, is instantiated with these inputs and outputs. The clock is then generated at 10 nanoseconds using the always block, and the simulation begins with the initial block where we reset the game, then place 3 bets on different positions, 32, 37, and 1 at varying wager amounts. After placing the bets, the roulette spin is triggered. Finally, the winning position, payout, and the player's final balance are displayed. The simulation ends, and the results are saved, readying itself for the next round. I'll now pass on to Nick, who will end it.
No!
Thanks for listening.
How do I end this?